Hey scholars, welcome back to chapter 17. We're looking at 17.2 today. What types of biological hazards do we face? So we're focusing on biological hazards or pathogenic types of hazards towards the human race. That's what we're going to look at today. So a couple of these diseases that we have to think about, or these different infectious diseases are can be spread from one person to another, but some of them are not infectious or transmissible, and they're called non-transmissible diseases. And one of those is asthma. That's an example. I have one of those. I have asthma. It's a non-transmissible disease. I inherited, I guess, from my parents. Maybe I had it in the womb, but it's not something I can give to the person sitting next to me. Or diabetes is another example of a non-transmissible disease. Infectious diseases are what we call pathogenic, which means they're usually caused by diseases of some sort or some sort of disease-causing agent, and that is really what pathogenic means. And then transmissible diseases can be contagious, which are easily spread, or communicable, which means they can be spread. And so those are a couple of our different types of disease that can be, as far as spreading from one person to the next. Since 1950, we've had deaths from infectious diseases, and they've been declining because of the fact that we've had better health care, antibiotics, and also vaccines overall. So we have had a lot of success with that, with our health care in the past 50, 60 years or so. One of the terms I want you to know is called disability adjusted life years, or DALYs, and that is the total disease burden in a single population. So for instance, probably as far as infectious diseases go, you're going to see a higher higher DALYs as far as a third world country than you would with a developed country, because they have medications easily given out to people, and people can afford it. So you would see a higher disease burden population in a third world country than you would with a developed country. So let's take a look at some of the major causes of death in the world in the U.S. and the United States in 2005. So we might not have, as far as infectious diseases go, a higher DALYs than maybe the world or third world countries, but we do have a higher in some categories, and one of those categories is cardiovascular diseases. So if you look at the United States, we're at 39% as far as our major causes of death. This is in 2005, so a while ago, versus the world 30%. Now, infectious diseases, we've got those pretty well covered. We're pretty maintained on our infectious diseases through different injections and medications that we have, and vaccines. So we're pretty good on those. We only have 7% of deaths of infectious diseases, only 30% worldwide. But cancers, again, we're high as well, and that's mostly because of our diet and lack of exercise and a whole bunch of other things that attribute to cancers. So 23% for us and 17% for the world. So let's take a look more at infectious diseases, and they are still a major health threat overall, not just with the U.S., but worldwide mostly. And they can be spread through a number of different things, through air, water, food, and also bodily fluids. And there's two terms in the book. One, epidemics and pandemics. Most of you, because you know that word, that pan versus epi. Pandemic is worldwide. Epidemic is when it's happening in one spot. Pandemonium, worldwide chaos. So that's just an example. I just want to know the difference in those two. Epidemics is at one spot in a located area, and a pandemic is worldwide. And so we have seen some struggles with this, and one of those is resistance of bacteria and insects. That's becoming a greater threat. We'll talk a little bit more about that a little bit later. This is kind of interesting. This is a unique, kind of a scary thought, but this is all the pathways that infectious diseases could be transmitted to humans. So they can come from pets, and they can come from livestock with the eating of food, wild animals, if you were to eat wild animals or have them encounter them in some way, insects, specifically mosquitoes or ticks or things like that would actually burrow and inject in your skin. Food, you can get that through food, water, and air. But also you can get other humans, and for females you can also give it to your baby. So you might even be you're at risk, and you haven't even been born yet. So those are just a couple of different ways and pathways that infectious diseases can come into contact with humans. This is a scary stat, but the world's 7 deadliest infectious diseases have killed 12.5 million people. The first one is the pneumonia and the flu, the common cold. It changes form every year, it mutates every year, which is why you have a new flu vaccine every year. But again, a lot of people don't have that in the world, especially third world countries. So 3.2 million people get that and die from that. HIV and AIDS virus, 2.1 million. Again, they might not be dying exactly from AIDS. They could, but again, most of them probably are dying from that pneumonia or flu, and then their immune system are weakened by AIDS. But diarrheal diseases, it's kind of gross, but it is true because of dehydration. 1.9 million, again, more towards third world countries. Tuberculosis or TB, transmitted similarly through like HIV through blood and bodily fluids. And a lot of times that goes unnoticed. You don't even know you have TB until you pass it on to somebody else. That's 1.7 million. Malaria is 1 million through protists and mosquitoes. They're the transmitter, but protists are the cause. And then 1 million for Hep B, and then finally 800,000 for the measles virus. So those are our top 7 deadliest killers as far as infectious diseases go. So one of the science-focused things that it's in your book, it talks about genetic resistance to antibiotics, which is why you watch the MRSA video every year as far as if you're an athlete for White Oak High School. And bacteria, this is where they rapidly reproduce. They easily spread. But a lot of times, because they rapidly reproduce, there's lots of different genetics involved with bacteria, or a little bit very different variations. And so if you overuse antibiotics or you overexpose them to pesticides, there's a good chance that a couple of them will be strong enough to be resistant to that, and then those ones will survive and through natural selection they'll pass that genetics on to their offspring, eventually creating a strain of bacterial resistant antibiotic resistant bacteria. And the same thing with pesticides. They become pesticide resistant pests. So that is a growing problem. You see it a lot more, especially with the MRSA in hospitals. We are seeing it increasingly throughout the world because of our overuse of antibiotics and pesticides in that regard. So there it is, MRSA, methicillin-resistant Staphylococcus aureus is the scientific name for MRSA, and is resistant to most antibiotics. Symptoms of MRSA are you could start off with a small sore, and eventually opens, pussiness, and eventually swelling, redness, and then eventually the blackening of flesh. How it will be controlled, scientists, a lot of what they're referring to is actually cutting the area around that out, since they are still doing a lot of increasing their dosage of antibiotics as well, and hitting it with many different types of antibiotics is helping to control it. But there is a scary thought as far as MRSA goes. That's why we show that video every year. Why is tuberculosis on the rise? Well, then again, we don't even know. Sometimes you don't even know you have TB until you've already passed it on, or it's too late, and not enough screening are done as far as control programs go. They are starting to see genetic resistant TB to a majority of the effective antibiotics, which is causing some problems again, kind of like MRSA did. Person-to-person contact has increased because there's more people in the world, and there's also, more, you're living closer to people. AIDS in individuals are also very susceptible to TB and tuberculosis as well. So those are a couple of reasons why the global threat to tuberculosis is on the rise. So there you go. TB, kind of a dangerous thing. Some of the viral diseases kill large numbers of people. The flu and influenza are our #1 killer. Again, it's very easily given to one another or transferred to one another. HIV is #2. They have antiviral drugs for that. Again, none of them are cures whatsoever. Global strategy to slow down the spread of HIV. We've seen reduction of the number of new infections. Concentrate on those most likely to spread HIV as far as the early reproductive years. We should try to do free testing overall and really educate for prevention. That's the best way of doing it. I remember hearing a story back when I was in high school that there were certain tribes that believed, in African third world countries, that if you had HIV and you had sex with a virgin, then you would no longer actually have the HIV virus. So education still is needed, especially in third world countries. Provide free and low-cost drugs instead of the expensive ones that are out right now for it, and continue to research to try to find cures for HIV. Hep B again, HBV virus, #3 killer. Very similar mode of transmission as far as sexual contact or through blood, and that is another reason for its #3. Viruses that move from animals to humans, like West Nile and the severe acute respiratory syndrome, or the SARS virus, is kind of a dangerous thing as well. Again, in order to reduce your overall infection or chances of infection, or your probability that you will get one of these diseases, is just wash your hands to keep yourself clean. As far as using clean water to wash yourself, and also soaps. Ecological medicine, we have seen this. There's some medicines. We obviously use a lot of plants to help fight things like malaria. I know they use a lot of rainforest trees, and they actually take some of their medication from those trees to help fight malaria. Human practices that encourage spread of disease from animals to humans, by not cooking meat well enough, having cattle too close, or just different animals around, your food products that you are going to ingest. Some of the emerging infections again have been HIV, SARS, West Nile, and Lyme virus from animals. Malaria is another one that we talk about, and this is a case study. The death by parasite-carrying mosquitoes. Again, mosquitoes aren't causing the malaria. It's the plasmodium or the protist that's being carried by the mosquito that's causing malaria. Because everyone gets bit by mosquitoes, it's easily spread or moved around the population. The symptoms are very, very much like a really, really bad cold, really bad flu virus, what it feels like. It never goes away either, which is a bad thing. The malaria cycle is, I don't know if we have a picture of it, but basically the mosquito, inside of it has the protist. They reproduce sexually inside the mosquito. When the mosquito bites the human, they actually put some of those protists inside the blood. Then they get transmitted towards the liver, where they reproduce asexually, and then they put it out the body, which causes the infection and the feeling of those symptoms. And then a mosquito might bite you, pick up some of that, and keep it going, the life cycle going. So that's kind of the malaria life cycle in a nutshell. We have seen malaria on the rise since 1970 because of there are now drug-resistant plasmodium or protists that are more resistant. We've seen insecticide-resistant mosquitoes, which is causing more transfer there. And the effects of global warming have increased as well. And as that happens, more mosquitoes and that disease will spread more north and south latitudes. AIDS patients are pretty vulnerable to that disease because their immune system is weakened as well. But there are more current research being done. Again, we already have all the causes. And the last thing we're going to look at today are infectious diseases. Again, reducing poverty, decreasing malnutrition, improving drinking water quality, and a number of these lists of things will help us in the future. We'll see you guys next time for 17.3.